హెవీ వర్డర్స్ వస్తారు, ఏం ప్లే అవ్వలేదు అనుకో.
Hello my dear students, welcome to IMS Gate Academy Gate previous year question series of communication system subject. So in the last class we have discussed the gate questions regarding the year 2016, and in the last class I have given one homework question. How many of you tried that question? All of you quickly respond. Okay, so whoever tried that question, you can mention your answer in the chat. Okay, whoever couldn't solve, okay, no problem at all. In this particular session I will give some more time for solving that particular question. After that, in this particular session we are dedicating the questions based on the questions which are asked in the year 2015, right? So we are going to discuss the selected questions which are asked in the year 2015, right? Okay, so I hope all of you are eagerly waiting for the session. So let us start. So this is the question I have given as a homework in the last class. Whoever tried by this time, so you can mention your answer in the chat. Whoever seeing this question very first time, no problem at all. Now all of you read the question. I will give some time. All of you can try, and what is the answer you are getting, you can mention in the chat. Hi Mohit, welcome to the session. Okay, so this is the question based on information theory concept, right? So first let us read the question. A digital communication system uses a repetition code for channel encoding and decoding. For channel encoding time and decoding time, they are using the repetition code. And here regarding the transmission, they have mentioned initially, during transmission, each bit is repeated 3 times. Suppose whenever they want to transmit 0, okay, instead of transmitting 0 for 1 time, they are transmitting 0 for 3 times. That means 000. Similarly, whenever they want to transmit bit value 1, they have transmitted 3 times 1, okay, 3 times 1. And it is assumed that the source puts out symbols independently and with equal probability. The decoder operates as follows. In a block of 3 received bits, okay, at the receiver, you see from the transmitter, when you are sending, for every bit you are sending, instead of transmitting single bit, you are transmitting 3 bits, right? Similarly, at the receiver, you are using the decoder. That time, just by considering 3 bits, you can decide whether the output you have to consider 0 or whether output you have to consider 1, right? So here they have mentioned regarding the decoder operation. The decoder operates as follows. In a block of 3 received bits, if the number of zeros exceeds the number of ones, that means what? The number of zeros are majority when compared to number of ones. That time, the decoder decides in favor of 0. That means the decoder is going to produce the output as 0. Similarly, if the number of ones exceeds the number of zeros, that means the number of ones are majority when compared to zeros, that time the decoder is going to produce output as 1. Okay. Assuming a binary symmetric channel with crossover probability. Crossover probability means, say for example, when you are transmitting bit value 0, ideally you should receive bit value 0. But instead of 0, if you are receiving 1, that means what? There is an error. Similarly, if you are transmitting 1, ideally you should receive 1 only, but instead of 1, if you are receiving 0, that means there is an error, right? So that is the meaning of crossover probability. In this case, they have mentioned crossover probability as 0.1. Okay. Now the question is, the average probability of error is. That is the question. Okay. So first of all, see, if you want, you can consider with respect to 0, or if you want, you can consider with respect to 1. For the time being, I am considering with respect to 0. Okay. Say for example, at the transmitter side, whenever, according to this given question, whenever they want to transmit bit value 0, instead of transmitting only 1 bit, they have transmitted 3 bits 0 like this. 3 bits 0 like this. Okay. So when you are transmitting 3 bits 0 like this, ideally you should receive 3 zeros only. Ideally you should receive 3 zeros only. But now can you guess what are the possible combinations you may receive at the input of the decoder? Ideal case is, if you are transmitting 3 zeros, ideally you should receive 3 zeros. So that what will happen? From 3 zeros, you can detect the output as 0. This is the ideal case. But now, can you guess what are the possible combinations? What are the possible 3-bit combinations that you can receive at the input of the decoder? Any guess? See how many bits you are having? 3 bits you are having. So if you are having 3 bits, you can represent all the combinations of zeros and ones with the help of 3 bits, right? You can receive any of those combinations. at the decoder input. Okay. Triple 0, 0, 0, 1, 0, 1, 0. Next combination you will get 0, 1, 1. So for the timing I am writing here. Zero, 1, 1, then 1, 0, 0. After that 1, 0, 1, then 1, 1, 0, then 111. So here I am considering the case that I want to transmit the bit value 0. So regarding that, I have used the repetition code. So I have transmitted 000. I have transmitted 000. So at the decoder output also, if you are receiving 0, that means there is no error. I want to transmit bit value 0, I have received bit value 0, so that means there is no error. Now here just observe regarding the decoder functionality, according to the given question, regarding the decoder functionality, what they have mentioned. Whenever if the, you can observe here, if the number of zeros exceeds number of ones, then the decoder decides in favor of 0, right? So here I am considering the case, in order to receive 0, here you can observe number of zeros is 3, number of ones here having how many? Okay, just for understanding, here I am representing one more column. Number of zeros and here number of ones. So this is the combinations you are going to get at decoder input, and here you are going to get output bit. Okay, here number of zeros is 3, number of ones is 0. Here number of zeros is 2, whereas number of ones is 1, Now just tell me, Mohit, what is the relation between number of zeros and number of ones? For all these 4 combinations, the relation between number of zeros and number of ones, whether number of zeros is greater or number of ones is greater when compared to other one. Whether number of zeros is greater when compared to ones or number of ones is greater when compared to number of zeros. Just you can observe, here 3 zeros are there, but here number of ones is 0. Here number of zeros are 2, number of ones is 1, right? So obviously number of zeros are more when compared to number of ones. So at the decoder, if number of zeros are more when compared to number of ones, according to the given question, output is what? Output is 0. So I have considered the case where at the transmitter side, I have transmitted bit value 0, that one with the help of repetitive code 3 times 0. Now if you are receiving at the decoder input, if you are getting any of these 4 inputs, you are going to get the output of the decoder as 0 only. So that means you have transmitted bit value 0 and you have received bit value 0. So that means, is there any error? No error, right? There is no error. For these 4 combinations, there is no error. Okay, right. Now just observe here, for these 4 combinations, what is the output at the decoder you are going to get? Now here if you observe, number of zeros is 1, for these 3 combinations, whereas number of ones are 2. Right, and last combination if you observe, there is no 0 at all. So that means number of zeros is 0, whereas number of ones you are going to get 3. Now for these 4 combinations, the relation between number of zeros and number of ones, it is making ulta. Right, earlier number of zeros are greater when compared to number of ones, whereas for these 4 combinations, number of ones are majority when compared to number of zeros. So at the output of the decoder, because number of ones are more, obviously the decoder is going to produce output as 1. Okay, now just observe, at the transmitter side, you have transmitted actually bit value 0, but at the receiver, you are going to get output as 1. So is it error or not? Yes, obviously it is error. If you have transmitted bit value 0, ideally you should receive bit value 0. But here, if you are getting any of these 4 combinations, for these 4 combinations, at the output of the decoder you are getting 1, so that means here you are going to get error. Here you are going to get error. Okay, I hope it is clear up to this point. Is it clear, Mohit? All of you please respond. Is it clear up to this step? Up to this point, is it clear or not? Okay, I hope it is clear for everyone. Now just observe here what they have mentioned. Assuming binary symmetric channel with crossover probability. That means if you have transmitted, in this case I have considered that I have transmitted 0, and if you are receiving 1, this is the crossover, right? 0 becoming 1. In order to get like that, the probability they have mentioned 0.1. Similarly, you can consider other example like 1 you have transmitted, that time if you are getting 0, that is the error, like that. Okay. So the crossover probability they have given 0.1. Now the question is average probability of error they are asking. Average probability of error. Average probability of error or probability of error all are same. All are same. Now here we have to focus these 4 combinations only, because we have transmitted 0. Suppose if you have transmitted 1, that time you will focus these 4 combinations like that, because when you are transmitting 1, output you are getting 0, that is the error. That is error. Okay, right. So for the timing, let us solve this question in 2 methods. So first let us solve the question in method 1. Method 1. So in the yesterday class we have mentioned the probability of error. The probability of error. Suppose if you are transmitting, okay, if there are n bits are there, out of which you are getting error in r bits. Okay, that time we have discussed probability of error formula as NCR into p power r into 1 minus p whole power n minus r. This formula we have already discussed in the last class, and I hope all of you studied regarding this probability formula, okay, in your mathematics subject as well. Okay, right. So here total number of bits are 3. Total number of bits are 3. N equal to 3. So out of 3 bits, now just observe here you are going to get output as 1, because number of ones are majority. So if you are getting number of ones 2, out of 3 bits, the moment if you are getting any 2 bits are 1, that time you are going to get output as 1. So that means one possibility regarding r we are considering 2. Okay. Then crossover probability, according to the question, crossover probability is 0.1 whole power r is nothing but 2 into 1 minus 0.1 whole power n value is 3 minus r value is 2. Okay. So from this tabular form, total you are having 4 combinations. Out of 4 combinations, 3 combinations you are having with respect to number of ones, you are getting 2. Any 2 bits, out of 3 bits, any 2 bits you are getting 1. Any 2 bits you are getting 1, right? So that means r value is 2. And one more combination we are having, all the 3 bits also becoming 1. All the 3 bits also become 1. So that means you are getting one more possibility for r value, that r value is nothing but 3. Out of 3 bits, okay, actually you are having initially all the 3 bits are 0, but due to any reason, if all the 3 bits become 1, right, so that time also you are getting final output as 1, right. So in this case, all the 3 bits you are getting error, right. So r equal to 3. Another combination, so 3C3, out of 3 bits, all the 3 bits you are getting error. Okay, crossover probability is same, 0.1. In this case, r value is 3 into 1 minus 0.1 whole power n value is 3, r value is 3. N value is 3, r value is 3. Okay, all of you do the simplification. 3C2 is same as 3C1. I hope all of you studied this formula, like NCR is equal to NCn minus r. NCR is equal to NCn minus r. So 3C2 is same as 3C 3 minus 2. 3 minus 2 is nothing but 1, right. 0.1 whole square, which is nothing but 0.01 into 1 minus 0.1 is 0.9 whole power 3 minus 2 is nothing but 1. Next. Now can you tell, Mohit, by using this formula, can you tell what is the expression you are going to get? 3C3 is nothing but, all other students also can respond. By using this formula, how we can write 3C3? Yes, it is very simple. N value you can keep as it is 3. C also you can keep as it is. Here we are using n minus r. N minus r. Here 3 minus 3, which is nothing but 0. 3 minus 3 is nothing but 0. Then 0.1 whole cube, which is nothing but 0.001. Okay, after decimal point you are having 3 digits. Power 3 you are having, right? Earlier 0.1 whole square. After radix point you are having, or after decimal point you are having 2 digits. Okay. 1 minus 0.1 is nothing but 0.9 whole power 0. Okay, so that means this entire expression you are going to get 1. Entire expression you are going to get 1. Now 3C1 is nothing but 3 into 0.01. Okay, 0.01 into 0.9, you can write it as 0.009. Okay, right. Next 3C0 is nothing but 1. 1 into 0.001, so you can write it as 0.001. Now multiply 3 with this term, so 3 9s are 27, and then you are having 0, and then radix point, and then 0, plus 0.001. So just add these two, how much you are going to get? It is very simple calculation, right? Just you have to perform addition of these two. 27 plus 1, you are getting 28, then 0.0. So this is the probability of error. Probability of error. So when you are transmitting 3 bits, ideally you should receive whatever the bits they have transmitted, you should receive ideally same. But for this question, you may receive, regarding those 3 bits, you may receive any of these 8 combinations. Out of 8 combinations, okay, if you are considering this example, if you are getting any of these 4 combinations, at the final output you are going to get 0, so that means there is no error at all. Okay, if you are receiving any of these 4 combinations, because of this you are going to get output as 1. So at the transmitter you have transmitted 0, but at the receiver you are receiving 1, so 0 becomes 1, right? So that is the error. Okay, so for these 4 combinations we calculate the probability of error. Similarly, if you have transmitted 1, with respect to that, here whatever these 4 combinations you are having, so for these 4 combinations you are getting output as 1, so that means there is no error. There is no error. For these 4 combinations, output you are getting 0, so 1 becomes 0, that is the error. So with the help of any of these 2 cases, you will get the same probability of error. Okay, I hope it is clear for everyone. All of you please respond, is it clear or not for everyone? All of you quickly respond. If you are having any doubt, you can ask in the chat. Okay, I hope it is clear. For the timing, for easy understanding, I have considered the example with the help of 0. Similarly, you can consider with the help of 1. And regarding that also, I have shown from the same tabular form. Okay, right. So this is the first method. Now we can solve the same question by using another method. So here if you observe, for these 4 combinations, we are not getting any error. Okay, with respect to this example, for these 4 combinations, we are not getting any error. Okay, right. So that means first let us calculate the probability of getting correct value. Okay, probability of getting correct. Okay, right. So for the timing, that one I am labeling as P suffix C. Earlier I have mentioned probability of error, now I have mentioned probability of correctness. Okay, similar formula we will use. Now here if you observe, here with respect number of ones, here only, here we not at all get any particular bit as 1. So that means number of ones is 0. Okay. For remaining 3 combinations, if you observe, since you are having 3 bits, at any time only one particular bit become 1. Okay, so that means 0 become 1 only at one particular bit position, right? So that means in this context, regarding R, you are getting 2 possibilities, either R value 0, either R value 1, right? So 3C0 by using this formula, 3C0 into probability, crossover probability, that is 0.1 whole power R is nothing but 0 plus 3C1 into 1 minus P whole power n minus R, okay. Now 3C0 is nothing but 1 into 0.1 whole power 0 is nothing but 1 plus 3C1 is nothing but 3 into 1 minus 0.1 is 0.9 whole power 3 minus 1 is 2. Sorry, 1 second. Here by using this formula, 3C0 into 0.1 whole power 0 into 1 minus 0.1 whole power 3 minus 0. Similarly here 3C1 into 0.1 whole power 1 P power R into 1 minus P whole power n minus R, right? So 3C0 is 1, 0.1 whole power 0 is 1, after that 1 minus 0.1, that is 0.9 whole power 3, okay, plus 3C1 is 3 into 0.1, okay, I will write once again, just 1 second. Okay, I will write this entire expression once again by using this formula. Here we are having 2 terms, right? NCR P power R into 1 minus P whole power n minus R. So 3C0 into P is nothing but 0.1 whole power R is nothing but 0 into 1 minus 0.1 whole power 3 minus 0. So this is the first term, Okay, actually earlier I have written only one term, but I have missed this one. Okay, right. Similarly, another combination, R value 1 we are considering. R value 1, 3C1 into here 0.1 whole power 1 into 1 minus 0.1 whole power n minus R, that is nothing but 3 minus 1, right. Now you can do the simplification. 3C0 is nothing but 1 into 0.1 whole power 0 is 1. Next, 1 minus 0.1 is 0.9 whole power 3, plus 3C1 is nothing but 3 into 0.1 whole power 1 is 0.1 into 1 minus 0.1 is 0.9 whole power 3 minus 1 is nothing but 2. All of you do the simplification of this one. How much you are going to get? Tell me. So regarding the first term, I hope all of you are getting this one, 0.729, and similarly regarding the second expression, you are going to get 0.243. So just perform the addition of these two. 3 plus 9, 12, 1 plus 2, 3, 3 plus 4, 7, 7 plus 2, 9. So you are getting 0.972. So 0.972 is what? You are getting the correct probability. That means you are transmitting 0, you are receiving 0. Similarly, you are transmitting 1, you are receiving 1. So that means there is no error at all. That is the correct probability. But in general, okay, in some cases you are going to get correct value, in some cases you are getting wrong result or error result, right? So if you are combining both, in order to get correct the probability you are having PC, in order to get error you are having some probability, and if you are adding both, sum of all the probabilities is equal to how much? I hope all of you can answer this question, right? Sum of all the probabilities is equal to 1, right? Sum of all the probabilities is equal to 1. So probability of correctness and probability of error is equal to 1. So from here actually we have to calculate probability of error. So that means probability of error equal to 1 minus correct probability, 1 minus the probability for getting the correct value, right? So whatever the value here you got, so you can subtract from 1. So from here you will get 1 minus 0.972. So here if you are subtracting, you will get the same answer, 0.028. See here 28 plus 2, 30, 30 plus 70, 100, 1 plus 9, 10. Yes, you are going to get same answer. So with the help of this method you can solve, or with the help of this method you can solve. Finally the same answer you are going to get. So based on your convenience you can solve by using any of these two methods. Okay, so in the previous method or first method, what we have done, we have focused the combinations where we are going to get error, right? So with the help of this one, directly you will get the answer. Okay, right. And in the second method, what we have done, in which combinations you are going to get, there is no error. There is no error means correct values you are going to get, right? For that we calculate the probability, and whatever the correct probability you got, from 1 we have subtracted, so that we are going to get the probability of error, Okay, so for this question you can solve with the help of first method or second method, you will get the same answer. But in general, why I have discussed second method, see for this question the method 1 is the best, okay? But in some cases, say for example, when compared to, like, regarding the number of combinations, especially where you are going to get error, if it is more number of combinations, by using this particular expression you have to do the simplification, right? For multiple terms you have to do simplification, right? So you can decide, but for this question, for 4 combinations you are getting correct value, for 4 combinations you are getting wrong result, right? So for this question, either with the help of method 1 or method 2 you will feel same, but the I mean to say, while solving this particular question with the help of method 1 or method 2 you will feel same level of simplification. But I mean to say for example, out of 8 combinations, 7 combinations you are going to get error, and 1 combination you are not getting error. Okay, in that case better you can follow second method, so that with the help of simple calculation by using second method you can easily get the answer quickly in less time, right? I hope it is clear for everyone when to follow method 1, when to follow method 2. Okay, right. So now let us solve the questions which are asked in the year 2015. Okay, so this is the question. Once again, this is the question related to information theory concept. So all of you can give a try. Yeah, whoever got the answer for this question, you can mention your answer in the chat, and whoever watching this lecture later, okay, so before watching the explanation part, just you can mention your answer in the comment section, right? Okay. So first let us read the question. The input X to the binary symmetric channel shown in the figure is 1 with the probability 0.8. See, here you are having binary symmetric channel, so you can transmit either bit value 0 or bit value 1. So regarding bit value 1, okay, they have mentioned the probability as 0.8. Okay, so once if you know, in order to get the bit value 1, the probability is 0.8, obviously the probability for getting bit value 0 is 0.2. Or in this question directly they have given, even if they haven't mentioned, okay, ultimately regarding X you are having two possible values, either you can represent 0 or 1. In order to get 1, they have mentioned probability as 0.8. So sum of these two probabilities is equal to 1, right? So in this question directly they have given regarding probability of getting X value 0 as 0.2. Okay. Now in this question, if you observe, if you are transmitting 0, ideally you should receive 0. If you are transmitting 1, ideally you should receive 1. Like that, if you are getting, that means there is no error, or in fact we can say that you are getting the correct bit. Okay. Instead of that, say for example 0 becomes 1 or 1 becomes 0, that means there is the error. Okay, it is crossover, 0 becomes 1 or 1 becomes 0, right? So in this question, okay, in order to get correct bit, the probability they have mentioned 6/7, and the crossover probability, 0 becomes 1 or 1 becomes 0, they have mentioned 1/7. And here also they have mentioned the same thing. The crossover probability is 1/7. Either 0 become 1 or 1 become 0, crossover probability, right? That is 1/7. Now the question is, if the received bit is 0, the conditional, they have given one condition. The conditional probability that 1 was transmitted. See, in general, when you are having, in any communication system, this is the transmitter, this is the receiver, and in between you are having the channel, right? After you are transmitting some bit, you will receive something. Okay, but now the question is, the probability that the received bit is 0, provided the transmitted bit is 1. The transmitted bit is 1. So that means here already you know the output. Okay, and that output because of this particular input, right? Now we have to calculate for this question. Just one second, I will represent the arrows here. Okay, so for this question we have to calculate probability of X equal to 1 given Y equal to 0. Probability of X equal to 1 given Y equal to 0, because what they have asked, the probability of received bit is 0 due to the transmitted bit 1. That is the question. That means probability of A given B, that means already output is given. Okay, and now we are calculating the probability because of this particular input. Now if you observe this particular binary symmetric channel, right, you are receiving bit value 0 because of two possibilities. Either you can transmitted bit, if it is 0, then because of that you can receive 0, or if the transmitted bit is 1, even because of that also you can receive 0. Like that you are getting two possibilities. Okay, now the question is, the probability of received bit is 0 due to the transmitted bit is 1. So that means I have written like P of A given B. So that means here already output is given. That's why I have written Y equal 0 here. Okay, whereas X equal to 1 here. Okay, I hope all of you studied regarding the conditional probability calculation like this in your mathematics subject in the chapter probability. You might have studied, okay, regarding the formula by using Bayes theorem and etc. But here we will use similar kind of formula only, but you no need to by heart. Just by observing this diagram. Of course, for understanding purpose, I am representing the mathematical equation, but once if you understand, then directly you can substitute the given probabilities and you can do the simplification in directly 1 or 2 steps. Okay, Just for understanding, I will represent the notation so that you never get any confusion at all. Okay, right. So now if you observe output, okay, here our requirement is what? Here our requirement is you are getting 0, okay, you are getting 0 because of transmitted bit is 1, because of transmitted bit is 1. Now according to this diagram, you can receive bit value 0 either because of input bit is 0 or because of input bit is 1. Two possibilities you are getting, right? Two possibilities you are getting. So for the time being, let us complete the denominator part first. Let us complete the denominator part. So here first of all, in order to produce 0 at the input side, you are having probability of x equal to 0. In order to get bit value 0 or in order to get the input bit as 0, you are having the probability of x equal to 0. Now after generating that particular bit, okay, because of that particular bit, if you are receiving bit value 0, because of this input 0, if you are receiving bit value 0, so that means I am representing like this: probability of output given input, so probability of y equal to 0 given x equal to 0. It's like P of A given B into P of B. You can observe closely, right? This is one combination. This is one combination. You are receiving bit value 0 because of the transmitted bit is 0. And in order to get the transmitted bit 0, you are having some probability. Okay, right. And you are having one more possibility. You are receiving bit value 0 because of the transmitted bit is 1, right? Because of the transmitted bit is 1. So that means okay, now I am considering the probability of x equal to 1. I am considering the probability of x equal to 1. Now because of this input 1, you may receive 0. So that means probability at the output you are getting 0, because of the input x equal to 1. Because of the input x equal to 1. Okay, I hope it is clear. This is the total probability. Okay, you are receiving bit value 0 because of two input values, either because of 0 or because of 1. So regarding each combination we have written, and if you are adding together, that is a total probability. Okay, now here condition is what? Here our requirement is what? We are receiving bit value 0 because of the transmitted bit is 1. Okay, now among these two we have to focus this particular term. Okay, suppose if they have mentioned the output, you have to calculate the probability of the received bit 0 because of the input bit 0, that time we will consider this one. Okay, but in this question we have to consider this one in the numerator. That's all. Probability of y equal to 0 given x equal to 1 into probability of x equal to 1. Okay, now you can substitute probability of y equal to 0 given x equal to 1. So that means 1 by 7 into probability of x equal to 1, they have mentioned 0.8. Similarly, whatever here you have written, same term here second in the denominator. So this part you can copy as it is. 1 by 7 into 0.8. Now let us write this expression. Probability of x equal 0, you are having 0.2. Into probability of y equal to 0 because of x equal 0. You are having 6 by 7. Okay. Now if you observe in the denominator, you can take 7 as LCM, and here also you are having 7. Okay, 7 will get cancelled. Just you can multiply the numerator part, that means 0.8 divided by here 6 into 0.2, that is nothing but 1.2 plus 1 into 0.8, that is 0.8. 1.2 plus 0.8, how much? 1.2 plus 0.8, 2. So 0.8 divided by 2, which is nothing but 0.4. It is a very simple question. Okay, for understanding purpose, I have written this whole equation, but for solving this question, no need to write this expression. Just observe the diagram. You are receiving output 0 because of two possibilities, right? So you consider regarding 0, how much probability, and because of 0, if you are receiving 0, whatever the probability, just multiply those two probabilities plus. And in order to get 1, how much probability, and because of 1 you are getting 0, how much probability, multiply those two, and that is the overall expression you are going to get in the denominator. And in the numerator, whatever here according to this question, what is the second term you are having in the denominator, that term we have to consider in the numerator. Suppose if they ask with respect to other case, then the first term we will consider like that. Okay, so the final answer for this question is 0.4. I hope it is clear for everyone. Okay, now I will show the next question. All of you give a try. This is a simple question which is based on the quantization regarding PCM concept. This simple question, so I will give 2 minutes only. All of you give a try. Yeah, time up. Whatever the answer you are getting, you can mention the chart. I hope all of you can answer this question. This is a simple question, direct formula based question. Right. So in this particular question, they have given the signal to quantization noise ratio in the order of decibels. In the order of decibels they have given. I hope all of you know regarding signal to quantization noise ratio in the PCM concept, especially when you are having in the decibels. So signal to quantization noise ratio, SQNR in dB, SQNR in dB is equal to 1.8 plus 67. You will get 1.76 plus 6n. So we can make it approximate like 1.8 plus 6n. Okay, right. So here they have given 31.8 decibels they have given. So which is equal to 1.8 plus 6n. So just bring 1.8 to the left hand side, it will become negative. So you have to separate these two numbers. How much you are going to get? You are going to get simple answer. All of you can answer this question easily. How much you are going to get? 31.8 minus 1.8, that is nothing but 30. So from here you are going to get n value as 5. So the number of bits you are going to get 5. The number of bits you are going to get 5. In this question they haven't asked regarding number of bits. If they could have asked regarding number of bits, this is the final answer. 5 is the answer. But in this question what they are asking? The number of levels in the quantizer. That means the number of quantization levels they are asking. So I hope all of you know the relation between the number of bits, used for every level and the number of levels that they have used in the quantizer. Okay, I hope all of you know this formula regarding the relation between number of quantization levels and number of bits. That is nothing but L equal to 2 power n, L equal to 2 power n. So just now we got n value 5, you can substitute here. So L equal to 2 power 5, so that is nothing but 32. So here they are asking the number of quantization levels, so those are nothing but 32. Okay, it is a very simple question, direct formula based question. Okay, I will show the next question. This is also directly formula based question. I hope all of you can answer this question correctly. Okay, so this is also a simple question, that's why I am giving only 2 minutes time. So all of you can answer this question. So whatever the answer you are getting, you can mention in the chart. Don't hesitate whether your answer is correct or wrong. No worry at all. Okay, so after solving this question, whatever the answer you feel, because you are having 4 choices, right? At least the earlier questions you are getting like NIT questions. Okay, but at least this question is MCQ. Among the 4 choices, at least you can try or you can guess whichever, after solving this question, whichever option you feel correct, you can choose. Okay. Yeah, time up. Whatever the answer you are getting, you can mention the chart. And whoever watching this lecture later, so before watching the explanation part, so just give a try, and whatever the answer you are getting, you can mention in the comment section, right? Yeah. So first of all, if you read this question, and you will come to know this is the question based on delta modulator concept, right? So first of all, let us read the question and let us parallelly note down the given data. Yes, very good Manoj, very good. Option A is the correct one. Yes, very good, excellent. So here in this question they have mentioned a sinusoidal signal of 2 kHz frequency is applied to a delta modulator. So that means this is the message signal or input signal or information signal, and which is having the maximum frequency as 2 kHz, right? So that means FM equal to 2 kHz. This is the maximum frequency of the input signal or message signal, okay, is applied to a delta modulator, and the sampling rate and step size they have mentioned like this. Sampling rate they have given like this, 20,000 samples per second. Sampling rate, FS, sampling rate or sampling frequency all are same, okay. They have given as 20,000 samples per second. 20,000 samples per second, okay, and they have given the step size of the delta modulator as 0.1 volts. Step size of the delta modulator as 0.1 volt. Now the question is, to prevent slope overload, the maximum amplitude of the sinusoidal signal in volts is dash. That is the question, okay. So in general, when you are using delta modulator, the slope overload distortion occurs because of you are considering the, suppose you are supposed to consider more step size, okay, but you are considering very small step size. Because of this one, you are getting slope overload distortion. Now the question is to avoid or to prevent slope overload. That means you have to increase the step size. Right? Okay. So here the condition to avoid or to prevent slope overload distortion. The condition to prevent slope overload. The condition to prevent slope overload distortion. The condition to prevent or to avoid slope overload distortion is here delta by Ts. Here step size you have to increase. That means this is greater than or equal to delta by Ts greater than or equal to. Hi Rakesh, good evening. Delta by Ts greater than or equal to AM 2 pi FM. AM 2 pi FM. Okay, right. So here 1 by Ts we can write it as sampling frequency or sampling rate, all are same. So 1 by Ts is nothing but Fs, which is greater than or equal to AM 2 pi FM. AM 2 pi FM. So whether you are having sine signal or cos signal, regarding that you can consider like dm of t by dt, that one magnitude you can consider, you are going to get AM 2 pi FM. AM 2 pi FM. Okay. Now from here, okay, let us rearrange this equation. Like if you are bringing 2 pi FM here, left hand side, now the relation you are going to get like this: delta into Fs divided by 2 pi FM is greater than or equal to AM. Okay. I have brought 2 pi FM here, so delta Fs divided by 2 pi FM, which is greater than or equal to AM. Now if you want, you can rearrange the relation like this. Okay. So if you want, you can represent the relation like this. This overall term is greater than or equal to AM. That means AM is less than or equal to this overall term, right? AM is less than or equal to delta into Fs divided by 2 pi FM. 2 pi FM. Okay. Now substitute the given values. Here delta is 0.1, and sampling frequency or sampling rate they have given 20,000 divided by 2 pi you can keep as it is into FM is 2k. So 2k you can write as 2000. 2k you can write as 2000. here you're having 2000, here you're having 20,000, so that means here 10 times, so 10 into 0.1 you are getting 1. Okay, so that means from here you are going to get AM is less than or equal to 1 divided by 2 pi. So the amplitude of the message signal should be less than or equal to 1 by 2 pi, so that we can avoid the slope overload distortion. Now if you observe this particular relation regarding the amplitude of the message signal, the maximum value that you can choose as 1 by 2 pi, and below or lower than this value, any value you can consider regarding the amplitude of the message signal, so that we can avoid the slope overload distortion. Right, now if you read the question carefully, they are asking what? The maximum amplitude of the sinusoidal signal in order to prevent slope overload distortion. That means here you are going to get option A as the correct answer. Right, option A is the correct answer. So regarding AM, the maximum value you are going to get 1 by 2 pi. 1 by 2 pi. So that means option A is the correct answer. Okay, so this is the direct formula based question only. Okay, so sometime in the exam you may get confusion that whether, sir, we have to use the relation like greater or less. Okay, if you remember the concept regarding slope overload distortion, in which case you are going to get, with the help of that, in order to avoid, that means you can consider, okay, slope overload distortion actually occurs because you are considering step size very small. Suppose you require step size this much, but you are considering only small step size. Because of that, it is occurring. Now, if you want to overcome that problem, that means you have to increase the step size. So that is the reason here we have to consider the relation greater than or equal to. Similarly, for granular noise, opposite relation. Okay, in the granular noise case, actually you are supposed to consider small step size, but you are considering more step size. In that case, you have to reduce the step size like that. Okay, so in that way you can solve either the question regarding slope overload distortion or granular noise. Okay, you can avoid the confusion. Even if at all whoever students are having any confusion, sir, whether we have to consider greater than or equal to or less than or equal to, okay, just recall the concept of slope overload distortion and granular noise, in which case it is occurring. So if you want to avoid, so what we have to perform with respect to step size, whether we have to increase or decrease. Okay, right. Okay, this is the last question, but okay, but this question I won't solve now in this particular session. I am giving this question as a homework. So all of you can try this question whenever you get time in the upcoming 1 week. Okay, so all of you can give a try. This is a question based on random variables. Okay, but for solving this question in this particular session, we have discussed the first question, right? So with the help of that probability concept, you can solve this question. Okay, right. So all of you can take the screenshot of this question, and whenever you get time, you can solve this question, and after solving this question, whatever the answer you feel correct, you can mention in the comment section. Okay, right. So with this, in this particular session, we have discussed good number of questions which are asked in the year 2015, and in fact the first question which I have discussed is from the year 2016. Okay, so I hope all of you are getting the confidence regarding communication system subject. So whoever missed the earlier sessions, no problem at all. So all the lectures which we have taught earlier in the live classes, live sessions, all the lectures regarding communication system subject, the gate questions which are asked in the year 2023 and then 2022, 2021, like that. Okay, up to the last class. Okay, whatever the gate questions we have discussed, selected questions which are asked in the previous years, we are discussing. So all these lectures available in the playlist of our IMS Gate Academy YouTube channel. Okay, so kindly visit in the YouTube, just type IMS Gate Academy and then just go through the playlist regarding communication system subject. You will get the playlist of the previous year questions of communication system subject. So kindly watch those lectures so that you will get maximum benefit from this series of lectures, right? So definitely it is going to add value addition for your gate preparation, okay, for the coming gate exam, right? So we are having upcoming YouTube live sessions in the next week, that is on 22nd November and 23rd November. So in that particular session, we will discuss the selected gate questions which are asked in the year 2014 and then 2013. right? So we'll meet you all in that particular session. So meanwhile, whenever you get time, whatever the homework question I have given, so kindly solve and you can mention your answer in the comment section. Okay, and kindly share these series of video lectures with all of your friends so that they also will attend these sessions. Based on the time possibility, they can attend the sessions in live, and due to any reason if they miss to attend the session in live, no problem at all, they can watch the recorded lecture whenever they get time. Okay, so that they also will get benefited from this series of lectures, right? Yeah, thank you Manoj, thank you Mohit, thank you Rakesh, and thank you all the other students who are attending this series of lectures in the live session and whoever watching this series of lectures in the offline sessions as well. Okay, later. Okay, thank you everyone. We'll meet you all in the next week, that is on 22nd November.